The ideal gas equation can also be used in stoichiometry. For example, when 1.567 grams of sodium hydrogen carbonate is reacted at 31 degrees Celsius and 1.2 atmospheres, how many liters of carbon dioxide gas could be produced? Now, I've done questions like this in the past using 22.4 liters per mole as a conversion between amount of a substance and liters of a substance, but that only works when the reaction is done at standard temperature and pressure. In this case, the reaction is done at 31 degrees Celsius and 1.2 atmospheres, which are not the standard temperatures and pressures. So instead of using that 22.4 liters per mole conversion, we can use the ideal gas law. Okay, so this is stoichiometry question. We're converting from one substance to another substance, and so we will start with what we always start with. We want to find the moles of our given. Our given is 1.567 grams of sodium hydrogen carbonate. So to convert between grams and moles, we use the molar mass of the substance. So to convert to moles of sodium hydrogen carbonate, we will use its molar mass, which is 84.01 grams and 1 mole. So now we've converted from grams of our given to moles of our given. The second step of stoichiometry is to convert from the moles of your given to the moles of the substance that you're asked about. In this case, we're going to convert from the moles of sodium hydrogen carbonate to what we're asked about, which is carbon dioxide gas. The way that we convert between moles of one substance to moles of another is by using the coefficients in the balanced reaction equation. In this case, you've been given an equation that's already balanced, so we look here. So we'll put a 2 in front of this, and then we look for carbon dioxide, which also has a 2, so we'll put a 2 here. The number won't always be the same, so this is a really important step, and don't forget to do it. If you put that all into your calculator, you will get 1.01865. I'm going to wait to round this till the end. Moles of carbon dioxide. Now we have moles of carbon dioxide, and the question is asking us how many liters of carbon dioxide could be produced. So we need to convert from moles of carbon dioxide to liters of carbon dioxide using the other parameters given us in the equation, or in the question. So we were given that the reaction happened at 1.2 atmospheres, so that's the pressure, and it also happened at 31 degrees Celsius, which let's just convert that to Kelvin right here. And we calculated just a second ago that the moles present were 0.01865. And our goal was how many liters, so that's a volume. So we can see that we're given P, T, and N, and we're asking about V. So this is a question that can be easily solved using the ideal gas law. We can rearrange it for the volume. So volume is equal to nRT over P, and then we'll just plug in the numbers that we calculated or were given. Our ideal gas constant is 0.8206 atmosphere liters per mole Kelvin. You can multiply this by 304 Kelvin as well. And then divide the whole thing by the pressure, which was 1.2 atmospheres. We can calculate that all out. It equals 0.39 liters. I'm rounding this to 2 sig figs because our pressure only had 2 sig figs to begin with.